Ever find yourself just buried under information, searching for that one key thing for your project? Or maybe you're looking at a job site. You need precise data, but the old ways just feel slow and expensive and kind of a pain to integrate. We've all been there. Today, we're really peeling back the layers on something pretty groundbreaking. It's changing how we capture and use spatial data. We're diving deep into affordable terrestrial 3D scanning. Specifically a partnership that's creating what some folks like Nik Smilovsky will mention later call engineering magic, the link between BadElf and Pix4D, our mission today. To unpack how this solution is helping people in government, utilities, construction, basically giving them access to accurate, cost-effective scanning that actually fits into how they already work. If you've maybe thought high-end 3D mapping was out of reach, this is where it gets really interesting. So let's get into it. For a long time, 3D mapping and laser scanning, they've been powerful tools, no doubt. But they always came with these pretty significant barriers. So what were these traditional headaches? What kept so many people from jumping in?
Yeah, it's interesting looking back. The barriers were pretty substantial. First off, the cost, just the raw cost. We're talking equipment, scanners, often running well over $100,000 easily, which meant, organizations either skipped it entirely or they had to hire these really expensive consultants just to get the data for a specific project, made it pretty exclusive.
Not accessible.
Not at all. And then beyond the money, there was the learning curve. It was steep. Teams could spend weeks, months, maybe even longer just trying to figure out how to use these complex LiDAR or photogrammetry systems effectively day to day.
So not plug and play.
Definitely not. The workflows are complex. Getting the data itself could be incredibly slow. You'd have these tedious setups, moving the scanner bit by bit across the site, kind of hopscotching, we called it.
Hopscotching, yeah.
And then you get the data, right? And processing it was, well, often a nightmare. You've got gigabytes, sometimes terabytes, of this dense point cloud data. Confusing, resource intensive. And the final hurdle was often integration. How do you get this massive data set into your GIS or your CAD software, make sure it all lines up, that it talks to your existing systems, throw in real world stuff like bad weather, messing up a scan day. You can see why a lot of people just said, oh, maybe not right now.
Yeah, it sounds like a lot of friction.
Yeah.
So if you're the person needing that accurate data, but without all those sucky agents, as one source put it, there just had to be a better way,
right?
A simpler path. And this is exactly where, our deep dive starts to pay off. It's where the surprising stuff happens. Two companies, BadElf and Pix4D, they came together with a really different approach, a novel one.
Yeah, stepping back a bit, BadElf, they've been around maybe 15 years.
Yeah.
Known mostly for making these really rugged, reliable GPS receivers. Started in aviation, marine, but now they're heavily into GIS and this 3D scanning space. And their key innovation here, the thing we're focusing on, is this bring your own device idea, BYOD.
BYOD, right.
They designed their stuff to just work seamlessly with the devices you probably already have, your iPhone, your Android tablet, Windows device, whatever.
Makes sense. Leverage what's already there. And then the other piece of the puzzle is Pix4D. They're a huge name in photogrammetry.
Absolutely. Pix4D, founded, I think, 2011 in Switzerland. They really pioneered turning simple pictures into super accurate 3D models. Pixels to points, essentially.
Pixels to points, okay.
They were big with drones early on, structure for motion photogrammetry. Now their software includes things like Pix4D Catch, that's the mobile app for scanning, Pix4D Cloud for processing, sharing, and Pix4D Matic for handling bigger data sets on your desktop.
So you've got BadElf's positioning accuracy, Pix4D's photogrammetry smarts. How do they actually combine to solve those problems we talked about earlier? The cost, the complexity.
It really comes down to this clever synergy. It's what Nik Smilovsky over at BadElf calls engineering magic. And it kind of feels like it sometimes. Picture this. You take your iPhone, maybe an iPad, you connect it wirelessly to a BadElf GPS receiver, say the BadElf Flex.
Okay.
Now, that BadElf unit, it taps into what's called an RTK network real-time kinematic, gets these super precise corrections down to centimeter level.
Centimeter level from a network.
Yeah. And that high accuracy isn't just for knowing where you are. It gets fed directly into the Pix4D Catch app running on your phone or tablet. So the BadElf becomes this high-accuracy GNSS anchor, basically. It ties everything together spatially, augmenting what Pix4D Catch is doing on your device.
So it elevates the phone's capabilities.
Exactly. It turns your everyday phone into a professional-grade 3D scanner.
That's pretty impressive, especially the accessibility part. But, for someone listening who needs data they can trust, Reliable data. How does this magic actually work? What's the tech? And crucially, what kind of accuracy are we really talking about here?
That's a really important question because it looks simple, but there's some serious tech under the hood. At its core, it's photogrammetry, which is, the science of getting measurements from photos. Been around basically forever.
All right.
Modern phones have amazing cameras. That's key. And then you add Apple's AR kit, for instance. It uses something called visual inertial odometry, VIO.
VIO. Great.
Think of VIO as the phone using its camera and motion sensors to figure out how it's moving and where it is in space, relative to its starting point anyway, like how AR apps work.
I got it.
But VIO is smart, but it drifts. Over longer distances or time, the errors add up, like trying to walk a straight line blindfolded for too long.
Makes sense.
And that's where the BadElf RTK GNSS comes in. It's the constant, super accurate external check. It keeps correcting that VIO drift. It gives you what surveyors call a solid point of beginning, a POB. You need that strong geodetic foundation. Nik Smilovsky has that great line, crud in is crud out.
Right. Garbage in, garbage out.
Exactly. Without that external accuracy lock from the BadElf, your digital twin, no matter how detailed, wouldn't be reliably placed in the real world.
So the BadElf is like the anchor, keeping everything tied precisely to real-world coordinates, even as you move around capturing data.
Precisely. And Pix4D adds another layer of smarts with an algorithm they call geofusion.
Geofusion.
Yeah, it intelligently blends all the data streams, the VIO from the phone's internal sensors, and that high-accuracy GNSS from the BadElf. It even weights them. So, like, if you go under a bridge and lose the GNSS signal for a second, the system leans more on the VIO to keep tracking, then smoothly snaps back to the high RTK accuracy once the signal returns. It's designed for continuous, robust accuracy.
Okay, that makes sense. What about LiDAR? We hear so much about LiDAR in new phones. How does that fit in, or does it?
Good question. Phone lidar is interesting tech, but for this kind of professional work, it has limitations. The range is pretty short, maybe 10, 15 feet, something like that. And the point clouds it creates can be, well, less dense, sometimes noisy compared to dedicated scanners.
So not quite pro-grade on its own.
Generally, no. It can be helpful sometimes, maybe for calibration or filling tiny gaps where photogrammetry might struggle, like on a blank wall or something really shiny. But for the main data capture, the photogrammetry engine in Pix4D, boosted by the BadElf accuracy, gives you richer, more detailed, more consistently accurate results for these applications.
Okay, so bottom line, for you, the listener needing precision, what kind of measurable accuracy can you actually expect from this combined BadElf Pix4D system?
We look at accuracy in two main ways. Absolute accuracy, that's how well the final 3D model is positioned on the actual Earth, tied to a coordinate system.
Okay.
And tests consistently show vertical accuracy around 1.6 centimeters and horizontal around 4 centimeters. And that's from a phone, remember, with the BadElf. It's really impressive.
That is impressive.
Then there's relative accuracy. That's about measurements inside the model, like measuring the distance between 2 points within your scan. And here, it's incredibly precise. You can measure down to millimeters. You could, count the threads on a bolt in the 3D model. It's that detailed.
Millimeter level, okay.
Yeah. Even for just augmented reality placement in the field, like for quick checks, you're looking at 5 to 10 centimeter accuracy, which is really good for AR.
Okay, the science makes sense. The accuracy sounds genuinely impressive. So the next obvious question for you listening is, how does this actually play out in the real world? What's the practical value? Let's look at some examples.
Yeah, a really big one is utility mapping. Think about mapping utility paint marks on a busy road. Normally, that's dangerous, takes time.
Right, cruising the street.
With this system, you can capture the whole area safely from the sidewalk in maybe 5 minutes.
5 minutes.
Yeah. And then back in the office, trace those utilities digitally in another 5 minutes. It drastically cuts errors in time, especially in those really messy spots, spaghetti trenches where everything crosses over.
Spaghetti trenches, I like that.
We've seen huge sites, like 350 acres mapped in just morning, and the utilities traced in 3 days. Compare that to maybe 6 weeks, the traditional way.
6 weeks down to a few days, that's
huge. It's massive for safety, efficiency, and just cost.
And we also heard from Tim Massey at National Grid. His experience really highlights how this solves specific costly problems for a big utility, right?
Tim's perspective was gold. National Grid deals with this incredibly dense network of gas mains, other assets, places like Long Island, New York City, super complex.
Yeah.
Traditionally, documenting all that meant surveyors on site daily. You'd get these paper drawings, often hard to read, maybe linked to some spreadsheet somewhere, disconnected. And the real pain point was when that info was wrong or missing. It meant sending crews back out, redigging holes.
Yeah.
Incredibly expensive.
I can imagine. Wasted time and money.
So what Tim's team did was build this GIS system where the scanned pipe geometry is right there, visually overlaid, searchable, intuitive. And here's the kicker he shared. Using Pix4D and Bad Elf helps them avoid mistakes that used to cost about $3,000 each time they had to send a crew back to redig a hole.
$3,000 per mistake avoided.
Per mistake. So avoiding just one of those mistakes basically pays for the entire scanning setup for a year.
Wow. It's a clear ROI.
It completely changes the game. It turns the contractors doing the digging into essentially digital data providers, improves accountability, accuracy, everything.
So you can pull up a record years later, see exactly where that pipe was laid, even after it's all paved over.
Yeah.
That's got to be a huge relief for anyone managing infrastructure. That's the aha moment.
Absolutely, and that versatility is key. You can use it to supplement drone scans, get data under bridges where drones can't fly, or assess the condition of concrete, like on a damaged column, figure out repair volumes, or calculate stockpile volumes on a construction site. It just delivers accurate, geo-referenced 3D data quickly with less hassle in post-processing. It makes the data easier to find, easier to use, turns it from just information into actual insights you can act on. Okay, so we've taken quite a journey here exploring this really powerful combination of BadElf and Pix4D, driven by people like Nik Smilovsky. We've seen how they've kind of dismantled those old barriers to 3D mapping the cost, the complexity turning it into something affordable, accessible, and really accurate that you can basically carry in your pocket. You've heard how your own phone or tablet can be part of this engineering magic, how concepts like the point of beginning ensure solid data, and how real-world uses in utilities and construction are saving serious time, money, and preventing those costly errors. So maybe a final thought for you to chew on as we wrap up. If avoiding just one of those $3,000 mistakes or making one complex data task much simpler could pay for this whole solution, how could you use this kind of accessible tech to change how your organization manages its data? How do you go from just collecting data to creating a visual digital file cabinet that helps everyone make faster, smarter decisions? Apparently, the resources are out there. Free trials of Pix4D Catch, even sample loaner units from BadElf's team. That path from, zero to hero in 3D mapping might be shorter and easier than you think. Keep exploring, keep learning, and keep finding ways to make your data work harder for you.